Hello students, let us start a topic that is stoichiometric of chemical reactions. You all are familiar with chemical reactions, which is represented by chemical equations. The stoichiometry, it means the quantitative relationship among the reactant and products in a reaction. Let us discuss the stoichiometry in chemical reactions. You are familiar with the chemical reaction, and chemical equation is a brief representation of a chemical change in terms of symbols and formulae of the substances involved in it. As you know that whenever you need to show the change, that is a chemical change, you are representing this chemical change in the form of equation. Let us take one example of equation here, chemical equation, that is formation of ammonia. Formation of ammonia, here the two reactants are nitrogen and hydrogen, and the product is ammonia. So usually in the whatever examples you have seen in the equation in the lower class also, we used to write the reactant on the left hand side and we used to write the product on the right hand side. This is a way of representing a chemical equation in which we are writing whatever reactants in the left hand side and we are making the sum in between the reactants and the product on the right hand side, and between them we use a arrow sign. It shows that reactant is converted into product. So this is the way of writing a chemical equation. You are familiar with this. What this shows the chemical equation here, it shows that the reactants are here nitrogen and hydrogen and the products are ammonia. Let us discuss what is stoichiometric coefficient. As in the same example, we can find out the nitrogen and hydrogen are combining to form ammonia. But look at that, when you make it balance at the time, you can find that there is one hydrogen molecule combines with 3 hydrogen molecule. So the stoichiometry of nitrogen molecule is 1 here. The stoichiometry of hydrogen molecule is 3 and it give rise to 2 molecule of ammonia. That means 2 is the stoichiometric coefficient of ammonia. So how you find out stoichiometric coefficient? Write a chemical equation, balance it, and after balancing it, whatever the number comes here, that is the stoichiometric coefficient. So here nitrogen, only one molecule is there, therefore stoichiometric coefficient is 1. In hydrogen, 3 molecules of hydrogens are there, therefore 3 is the stoichiometric coefficient of hydrogen and 2 is the stoichiometric coefficient of ammonia. So whichever example is given to you, you need to balance it, and whatever number comes in each reactant and product, that number is taken as the stoichiometric coefficient. While representing an equation, we used to write G, S, L or AQ in brackets as shown in the example. Here G is written in the bracket with nitrogen, hydrogen and ammonia. Why this G is written? Because the G represent here the gas. That means while writing an equation, we used to represent the physical state of the reactant and product by writing G for gas, S for solid, L for liquid and AQ for aqueous. So that means while representing an equation, we are also representing the physical state of reactant and product by writing the letter G. If it is gas, we are writing G in the bracket, and others. So in this equation, we know that nitrogen is a gas, hydrogen is a gas, and ammonia is a gas. So we are writing G in brackets for nitrogen, hydrogen, and ammonia. So this is also an important representation in the chemical equation. There are different ways of defining a chemical equation. Let us define the chemical equation in terms of mole. This equation can be defined in this way. 1 mole of nitrogen react with 3 moles of hydrogen give rise to 2 moles of ammonia. Let us define the equation in terms of molecules. When 1 molecule of nitrogen react with 3 molecules of hydrogen give rise to 2 molecules of ammonia. So this is the definition in terms of molecule. In terms of mass, how we can define this equation? As we know that the mass of N2, that is the mass of a nitrogen molecule, is 28 gram, that is the molar mass, and the mass of hydrogen is 2 gram, because here there is 3 times hydrogen, therefore we need to multiply 3 into 2. And here the mass of ammonia is 17 gram, the molar mass is 17 gram, but the 2 times of ammonia is there, therefore you need to multiply with 2. So let's check what will be the mass here. For nitrogen it is 28, and for hydrogen it is 3 into 2, because 3 times of hydrogen is there, and 2 into 17 for ammonia, because 2 times of ammonia means 2 into 17. So how we can define in terms of mass? That when 28 gram of nitrogen combines with 6 gram of hydrogen give rise to 34 gram of ammonia. So we can define the chemical reaction in terms of mass also. Once again I will define for you. That is 28 gram of nitrogen react with a 6 gram of hydrogen give rise to 34 gram of ammonia. Just check the left hand side and right hand side. When you make the sum of this, you will be getting this. That means the LHS is equal to RHS. That is nothing but shows that in a chemical reaction, neither the mass is created, neither the mass is destroyed. That means the mass before the reaction and after the reaction is same. That is law of conservation of mass. So this is the definition in terms of mass. Let us define this in terms of volume, because this is only applicable for the gases. We can define in terms of volume, and as we have discussed in the mole concept, at standard temperature pressure, 1 mole of any gas having 22.4 liter of volume, any gas, that means if the gas is nitrogen, hydrogen, ammonia, any gas at standard temperature pressure, it occupies 22.4 liter volume. So how we define this reaction in terms of volume? That is 1 N2 means, that means 1 mole of N2, that means 1 mole having 22.4 liters. So we can say that 1 into 22.4 liter of nitrogen combines with 3 into 22.4 liter of hydrogen give rise to 2 into 22.4 liter of ammonia. Once again, here why I have multiplied with 1? Because there is 1 mole of nitrogen. This is 1 mole of nitrogen. So therefore 1 into 22.4. 3 mole of nitrogen, 1 mole have 22.4 liter. So 3 mole have 3 into 22.4 liter. Similarly, 2 moles of ammonia means it have 2 moles, therefore 2 into 22.4 liter. So how you define this one? Once again, 1 into 22.4 liter of nitrogen combines with 3 into 22.4 liter of hydrogen give rise to 2 into 22.4 liter of ammonia. So in this way we have discussed a chemical reaction in terms of mass, in terms of moles, in terms of number of molecules, and all are exchangeable. We have discussed in the mole concept, we can exchange the mass into mole, mole into number of molecule, number of molecule into moles, and moles into mass. So we can define an equation in terms of mass, moles, and number of molecule. Now I am giving one equation for you. This is an equation, that is methane. CH4 is the methane, combines with the oxygen, give rise to carbon dioxide and water. So it's a balanced equation is given. You need to define this equation in terms of moles, molecule, mass and volume, as done for the previous example, that is a formation of ammonia. In the same way you have to define this equation, and also you need to mention which one is the reactant here and which one is the product, and also shows that the mass of the reactant is equal to mass of the product. That means the proof law of conservation of mass in this equation. You do this work in your notebook and send into the assignment area. So this is all we have discussed about a chemical reaction, the stoichiometric coefficient in a chemical reaction, and which are the reactants, which one is the product, on which position we used to write reactant, and on which side we are writing the product. And we have defined the reaction in terms of, that means we have defined an equation in terms of moles, molecules, mass and volume. So this is all we have done in this video. So thank you everyone.